All right, so guys, we are going to do another lab that has you do a stoichiometry calculation, right? Using the before, the change, the after columns on that BCA table chart. So I'm going to go through a lab with magnesium, and we're going to burn that magnesium with the Bunsen burner, and it's going to react with oxygen that's in the air, right? And then we're gonna combine the magnesium and oxygen in a synthesis reaction to create magnesium oxide, which is MgO. Right. So that equation that you have on your sheet, it's two Mg's plus O2 produces just one product, two MgOs. Okay. Right. So we got this like strip of magnesium here. We're gonna light it in the burner. Right. It's gonna react with the oxygen in the air, and then we'll be able to measure how much magnesium oxide we get from this. Right. So we're kind of looking at this like the same thing we did. We just finished that nail lab. Right. In the beforehand, we figured out what we had, the amounts of things the grams that we had, we converted those to moles. Right. We figured out that the nail was the excess reactant. So we used the blue stuff, the copper chloride in our BCA table. And then we figured out how many grams of copper was made or should have been made, and then we found the percent yield. So we're going to do the same thing again today, right? So magnesium reacting with oxygen in the air. Now, which one of those two is the limiting reactant and which one is the excess reactant? Or which one's going to run out first, this piece of magnesium or the oxygen that's surrounding me in this room, right? It's the piece of magnesium. So when we get to our calculations, we're just not going to worry about the oxygen because the oxygen's excess. So let's see. It's got to go on. So we're going to have to again take some. We're going to have to take some mass measurements. So in our data, that's what we're going to do before we start here. So in our data table, we are going to fill in. First thing it asks you to mass this watch glass, this piece of glass here. So we're just using that as we're going to put our piece of magnesium on that so it doesn't like burn the table down or anything. Okay, so you need to just record the mass there of the watch glass, which is 14.76 grams. Okay, so that goes in the mass of an empty watch glass, 14.76. Okay. Then we also need to know the piece of magnesium here. So I'm going to put that on there. That's going to be pretty light, I think. Yeah, 0.07 grams, right? 0.07 grams. It was just a small piece of magnesium. Okay, so 0.07 grams of magnesium. Right, and so we're burning 0.7 grams of magnesium. Now, before we do our lab, I need you guys to do the calculations. At least the calculate for the theoretical yield. Right, we can't do the actual yield until after the lab. So, like I said, so can you guys work on that BCA table and get the theoretical yield for grams of magnesium oxide, right? So our steps, we know the grams of this, we got to convert it to moles, right? So we need the molar mass from our periodic table for magnesium, okay? And then however many moles that is, that goes in your BCA table for the before, right? We know we're going to use all of that. Okay. Then you're going to set up your ratio to convert between magnesium oxide. And then that magnesium oxide, that number of moles, you're going to convert that to grams of whatever the mole times, whatever the molar mass of MgO is. And then we'll have our theoretical yield. Okay. So guys, I need you to stop the video. Okay. I need you to stop the video here and do those calculations. Okay. So stop the video, do those calculations. Then we will come back and we'll do the experiment. Okay, I just needed to grab some goggles there before we go ahead and do our lab here. So we got the Bunsen burner. Get that thing lit. All right. Oh, I'm gonna shut the lights off. Well, I should probably reverse this so the window is not in the way. Yeah, the best I can is maybe some light from somewhere else. But we got our Bunsen burner. Let's see if I can tighten this a little bit. Yeah, now we got that blue. See that bright blue flame on the inside? That's what we want. That's the real hot part of the flame, right about right there. So I'm gonna just put the piece of magnesium here in these tongs. In these tongs, and I'm just gonna put this in the flame. Okay, let's see what happens. Yeah, it's glowing on the screen. I can see that. Okay, so turn that flame off. Put the lights back on. And then we got this like on my watch glass here, we got this like whitish, we got like a white solid here. Okay. We got a white solid. It looks like some of it maybe didn't totally, some of it didn't completely burn. I think the part that was like blocked by the tongs maybe didn't totally react. So we got a little bit of silver left, but that's okay. A little bit of like shiny magnesium left, but that's fine. We got a lot of white magnesium oxide powder here. Okay. So then the last step is, so this is where we need the watch glass, right? So we're going to weigh those two together now. And let's see how much magnesium oxide we got. There you go. 14.80 is the mass of the watch glass plus the MgO. Okay, so 14.80. Probably going to subtract the watch glass away from that. So you're going to subtract the watch glass away from that, and then you guys can calculate what the percent yield is, right? Compared to this is that'd be the actual yield when you subtract those divided by the theoretical yield that you